Hello everyone and welcome to Chapter 5, Sensation and Perception. So you may have noticed that Chapter 5 is a little bit longer than the other chapters. It's about 40 pages. Okay? So what I've done is I've divided it into the seven sections here. The plan is that I will go over sections, the introduction, go over sensory processes. Then I'm going to show you how to break down the different sections going forward to help condense your notes and make things easier to study. And then I will be providing slides for uh, the rest of the unit here. Okay. It is a long unit and I don't want to be having a 45 or a 1 hour minute video. Okay, so let's start with the introduction to sensation and perception. So what I'd like to do is start with, this is a very short video that gives you an overall sense of what I'm going to be talking about in this 10-minute video. Okay, so it's basically how sensation and perception work for us to give meaning to the data, the raw data that we receive from the environment every day. Okay, so we'll watch this. It's about a minute and a half. And then we're going to go back to the beginning and start from the definitions of sensation and perception and how they work.
Bypass Publishing presents Psychology in the Fast Lane. Difficult topics explained. Information processing in the brain. Sensation and perception are complementary processes that allow us to experience the world. The terms sensation and perception are often used interchangeably, but you'll soon see that they're distinct processes. Sensation is a passive process that brings information from the outside world into the body and into the brain, while perception is an active process that involves selecting, organizing, and interpreting information that's been brought to the brain by the various senses. Sensory organs begin the process by absorbing energy from a physical stimulus in the environment. Sensory receptors then convert this energy into neural impulses that are then sent into the brain. When the brain receives the neural impulses, it organizes the information and translates it into something meaningful. This is referred to as perception. The brain has the ability to discriminate between what is important and what is irrelevant, sorting interference from relevant input. We are constantly comparing information being received with what we have already encountered. How we perceive the world is a function of our past experiences, culture, and biological makeup. To view examples of perception, including the patterns of top-down and bottom-up processing, visit our Difficult Topics YouTube channel and view the video titled Top-Down and Bottom-Up Processing.
Okay, so I think that was a pretty good warm-up to sort of summarize where we're going to be going in this video. And hopefully that gave you a good groundwork of where to start. The study of sensation and perception in psychology, it's a area of study that focuses on learning how our senses, our eyes, our ears, and different sense organs detect stimuli from the world around us, and they transfer that stimuli into signals that the brain processes and attributes meaning to. So that's an area of psychology that usually in year 2 you can specialize in, and it's quite interesting. There's a lot of experimental research that goes on in this field. So how is sensation and perception sensation different? So as the video said, the terms sensation and perception are also often used interchangeably, but they're actually two very different systems. Okay, so sensation is the stimulus detection process. It's a process of receiving raw data via our 5 senses, and it's a biological procedure. It's passive. We don't do anything actively to pursue this. We sit back and the data comes in through our organs into our brain. Once this raw data is received by our sensory receptors, this information is translated into neural impulses, which is the only language that our brain understands. So perception is a very active process. It is the process of the brain interpreting the data, which results in us giving meaning to the information that's received. It's a more psychological process than sensation, where the person's past experiences and previous learning, memory, everything affects perception. So you may be wondering, how do past experiences and learning and memory, how does that possibly affect the perception of data that's come in through the sensory organs? And we're going to look at that next. The text breaks down the steps from sensation to perception into 6. Okay, so first the stimulus is received by the sensory receptors. The receptors translate the stimulus properties into nerve impulses. That is called transduction. Okay, the translation of physical energy into nerve impulses. Next, feature detectors analyze stimulus features. Okay, feature detectors break down and analyze the specific features of the stimuli. Next, stimulus features are reconstructed into a neural representation. Okay, so this raw data that's come in, and it's been reconstructed into this representation. And this neural representation of the new data is compared with previously stored information in the brain. That is the memories, the learning, the previous, any previous experiences that you may have had. So your brain is comparing the new neural representation with representations that you already have in your brain. Okay, so this matching process results in recognition and interpretation of the stimuli. So one example of how this the comparison and also the context, okay? It's comparison against previous memories and experiences, but it's also within context that this comparison is made, okay? So how about if everybody can close your eyes and just for the sake, let's have a purple background and imagine the number 13. Okay, so just a white 13 or a black 13, whatever you're doing, against a purple background. Okay, so it's just a number. That's all it is at this point, right? So if we go to the next slide here, can you see the middle there, the number 13 again? It's just the number 13. But on the top line, the number 13, with the letters A and C, your previous experience with A and C has your brain interpret the 13 as a B. Now it's a B. Okay? And then on the bottom line, your previous experiences with the numbers 12 and 14 is now having your brain interpret that as the number 13. So the context within which the raw data and the representation exists helps shape your perception of it. The second section of this chapter, okay, looks at sensory processes. So first we're going to look at, we're going to review sensory processes and talk about it within the context of psychophysics. Okay, then we're going to look at absolute threshold, signal detection theory, difference threshold, and sensory adaptation. So before we get into psychophysics, I want to review about senses. Okay, So the question, how many senses do we have? Generally, we talk about having 5 senses, right? Sense of smell, sound, sight, taste, touch. We learn that starting in early elementary, and those are the 5 that people talk about. But when you're wanting to look at sensation and perception, and when you start to study it more deeply, senses are where your sensory receptors are, where it pulls in the raw data, and that data is going to be transformed into the neural representations, right? It's not just coming like from your eyes, there's not just one. For example, your eyes are going to take in sensory information through the rods, which detect light, and the cones, which detect color. So there's 2. Okay. So for your ears, another one, your ears are going to take in sensory input with regards to sound, which is going to get into tone and pitch and all of that, right? But it's also going to be giving your brain data around balance. So your ears have at least 2 and more. So you can see on the right there, it sort of talks about the sensory system, visual, auditory, gustatory. Look at touch. Okay, so the simplistic picture there has just touch, but if you really look at it, you've got your sensory organ is your skin, and that takes in raw data around temperature, pain, vibration, texture, everything. The same with kinesthetics, which is muscle and tendons. It's taking information about the sense of body position, movement, whatnot. So sensory systems. So humans and animals and all living things, right? Their sensory systems are designed to extract from the environment the information that we need to function and survive. So sensory processes and the systems there are adaptive. They're adapted to the environment in which you live. Okay, so that can be seen, say, carrier pigeons, right? Um, for them to, I'm using GPS as a verb, for them to GPS around the earth, and travel long distances, their adaptation for sensory systems, they use the Earth's magnetic field to navigate. Okay, sharks, they sense electronic currents coming through the skin of their prey when they're deep in the ocean searching for food. And so the necessity that they have to do that has made it so that that particular sense has evolved to get stronger and stronger. So for humans, vision is our dominant sense. 80% of what we learn out of the world comes to us through perception, through vision, and a secondary strong sense with humans and animals is our secondary strongest sense is sense of smell. And you can imagine maybe it's also the same strongest senses with animals, dogs, a sense of smell. And possibly you can imagine how that would be adaptive in terms of avoiding danger. It helps greatly, especially with animals, in terms when they're out foraging, that if they were to come across an injured animal or a dead animal, that they can, due to their sense of smell, they can smell whether that particular food has gone rancid or is dangerous in some way and they should not be eating that. Psychophysics is the scientific area that studies the relations between the physical characteristics of stimuli and the sensory capabilities. Okay, so they are concerned with 2 types of sensitivity. Absolute limits of sensitivity. For example, what is the softest sound a human or animal can detect? And differences between stimuli. How much difference must there be between 2 tones for a human or animal to tell them apart? So now we move into stimulus detection and the absolute threshold. So the absolute threshold is concerned with how intense a stimulus has to be before you can detect it 50% of the time. The lower the threshold, the higher the sensitivity. So psychologists concerned with sensation and perception would do experiments, say, detecting, like in humans, with the 5 different sensory organs, what are the absolute thresholds for each of the sense modalities, say vision, hearing, taste, smell, touch. Okay, and there's this chart. There's a chart on in the chapter about page 144 that's concerned with that, which you can check out. For example, for vision, a candle flame can be seen approximately 50 kilometers away on clear dark night, 50% of the time. Signal detection theory is concerned with the factors that influence sensory judgments. It states that the detection of a stimulus, it depends not on just the intensity of the stimulus itself, but it also depends on the psychological state of the individual, which is basically how much they're paying attention. Okay, so a sound, there's a little experiment in there, and I suggest you sort of go over it. When there's a small sound, okay, there's two aspects that are going to make that participant say hit, right? One is going to be, did they hear it? And two is going to be, how much attention were they paying? And you can manipulate that or adjust that by increasing the rewards for the hits or the costs for the misses, right? That's going to result in lower detection thresholds. Experience also plays a role in signal detection. For example, driving, lower thresholds for detecting dangerous situations. So for example, when you were learning to drive, right? And you're learning to drive, and let's say that there's a parent sitting in the seat beside you. And usually when you're learning to drive, it's in our cars and we're kind of freaking out because we're afraid you're going to make a mistake. But anyways, my point is that the experience of the person in the passenger seat, due to that experience, they have a lower signal detection, a lower absolute threshold for danger. Okay, so you're driving up the street. You know, I can see that we're about to merge shortly, and if we don't, we're going to crash into the tree. I can see that there's a squirrel to the right that might jolt out into the laneway, and you can also see that there's two people walking on the other side. That's due to experience, many years, right? Whereas a brand new driver may not see those things. They have a higher absolute threshold for danger. Okay, so they may not see the merge coming up. They probably noticed the squirrel before the people, who knows? But the fact is, experience plays a definite role in signal detection, and also shows that to a certain degree, perception is a decision. So here's that chart I was talking about to do with the absolute thresholds for various senses. If you remember, absolute threshold is how much, at what level someone, human, animal, whatnot, can detect a stimulus 50% of the time, right? So for humans, I gave the example of vision already. So for humans, say hearing, the tick of a watch under quiet conditions at approximately 6 meters. So a human can hear that 50% of the time. For smell, 1 drop of perfume diffused into an entire volume of a large apartment, 50% of the time. Of course, some people have very strong reactions to perfume, and they are going to have a lower absolute threshold based on experience. So difference threshold. The difference threshold is defined as the smallest difference between two stimuli that people can perceive 50% of the time. It's also known as J&D, just noticeable difference. So you'll see there below, sound, weight, and taste, they're all represented there with fractions. And what this is that German physiologist Ernest Weber, he noticed that there's, as it says from the text here, some degree of lawfulness in the range of sensitivities within our sensory systems. And what these fractions mean is, for example, if you were to lift a weight that was 50 grams, If you were to hold a weight that's 50 grams in one hand and 50 grams in the other hand, obviously you're not going to notice that difference. If you were 50.22 grams, you're not going to notice the difference. You would need to have the other one be 51 grams in order for you to notice the difference, and that would be the JND, say the kinesthesis lifted weights JND, right? Sensory adaptation, that is diminished sensitivity of our sensory receptors to constant stimulus. Okay, which is a complicated way of saying basically your body is constantly being bombarded with data and information that's coming in, right? Your senses, your eyes, your ears, your nose, everything is being bombarded with information. So the function of sensory adaptation is that constant stimuli in the environment, your body stops really sensing those. Okay, it stops paying attention to those. And the reason it does that is because, okay, imagine you're sitting at your desk and you've got your hands on your table. Okay, you're leaning forward and you've got your hand rest up against your chin or however you're sitting. So your body is being bombarded with, my hand is touching my face, my arm is touching my desk, I've got my legs crossed and my pants are pushing against my knee there, and I've got socks on because my feet are cold. If your body is constantly sensing and interpreting that information, then it's not paying attention to any new dangerous information that may be coming in. I'm so busy focused on my pants and my socks and my hand on my face and my arm against the desk that I don't notice the intruder that just broke in the house, right? So your body stops paying attention to all of that information so that it can be alert for new information. That is sensory adaptation. It's also how, got that picture of that lady there living beside the train. Have you ever been to somebody's house who, they're living by a train or a very, very busy road? They don't notice it anymore. I mean, she's smiling. She's happy to be living beside the train. She probably doesn't hear it. Whereas if we were to go there, we have not adapted to that sound, and we would hear it every single time. That's just another example. So I've taken this from the text, just for you to have a look at. These are the Weber fractions for various sensory modalities. Okay, we talked a little bit about the lifting weights one, the 1 to 50, and there's some other examples there that you could look over. I'm not suggesting that you memorize these, okay? It's that you understand the concept, okay? So that, for example, on a test, if it were to give a different fraction, you would understand what that fraction means, not memorizing the loudness Weber fraction is 120, okay? But that you understand that, say, if you were to be listening to a sound that's 20 decibels, you would need to, if another sound was introduced into the room that was 20 decibels, you're not going to notice the difference because there is none. But if another sound was entered the room that was 21 decibels, that's when you're going to notice the difference. Okay, so that is the second part. Psychophysics, absolute threshold, signal detection theory, difference threshold, sensory adaptation. I suggest that for studying purposes, take out the main points of each one. Don't write a paragraph, the main points of each one, and be able to give an example so that you understand it. Okay, the third section is the sensory systems. So what I'm going to do is show you how to break that down, give you some suggestions for notes, because it does look like a lot of information, but like I said, if you chunk it, like our brains like to do for memorizing and learning, it will be much easier. So the three different main sections are vision, audition, and taste and smell. So for vision, these are the main parts. Eye, that says human eye in the book. Photoreceptors, visual transduction, brightness vision and dark adaptation. Color vision. Under color vision, there are 4 pieces. And then lastly, analysis and reconstruction of visual senses. And they're going to talk about feature detectors. Okay, so like I said, my suggestion to you is to read through the text, take out the main points out of each section, and make notes here. I am going to upload slides for the rest. We're already at 25 minutes for this video, so it's longer than a lot of you like. So I'm going to upload the slides tonight and tomorrow. Okay, so they will be there available for you. If you have any questions at all, please feel free to email me, and we can set up a time to chat, and I can give you hints or maybe study tips on how to learn all this information. Okay, fantastic. All right, good luck with the rest of the chapter, and I will see you next week.